And it is an honor to open the day one with the first vendor presentation. I promise to keep it light on sales and more informative on what is happening with the weather radars in Africa. So I focused my presentation on Africa, but actually it turns out I haven't been in South Africa for 3 years. Last time I've been here was 2022 with the event. Then we had a 1-year break for medical reasons, COVID, and now we are back. So that's great. It's actually my 10th visit to Africa, which I calculated in the last 3 years. So it's been one of my continents to go to. And it's always been one of the favorite places to visit. Just a brief information on what we do in general. We do weather radars. We are based in the Czech Republic, Prague, so we manufacture in Europe. And we have a mission to protect the people globally around the world, meaning everywhere, protect them from the effects of climate change and dangerous weather. And we try to do that by manufacturing one of the most important instruments in the measurement chain, which is a weather radar. It's already mentioned here by the gentleman from Mauritius that they are very happy with their S-band weather radar. And we would like to bring a sustainable weather radars to Africa that will actually work for a long time. This is the current projects that we are involved in. So we have grown in the last 5 years from the European supplier of weather radars to a global supplier of weather radars. You can see the projects, even the one that we haven't announced yet. With ICAO, we are supplying 5 radars to the Pacific, to the Pacific Islands of Tuvalu, Marshall Islands, Cook Islands, Niue, Palau. But this presentation will focus on Africa, on the projects that we do here on the continent, because I think they are more relevant. We can share some experiences that we have with those. Just one of the projects I'm very proud from last year, and it's been one of the crown jewels in our project. It is the radar in the Pacific island of Tonga, which was done in collaboration with ESPRED, the Southern Pacific Regional Association, for the Kingdom of Tonga, with a major contribution from the New Zealand Met Service. It was a project that had to happen very quickly, so we had to deliver the whole project. So whatever you see on the picture, which means the weather radar itself, which is the C-band weather radar, the tower, solar panels as a source of power, communication. We had to ship everything to the other side of the planet. It's actually the furthest place you can get from the Czech Republic. If you point a needle through Prague, the core of the Earth, it comes out near Tonga. So it cannot be further. It's a 35-hour flight. So good luck to everybody who's going to do that on economy, which my team had to. But at the end, it worked out really well. It was inaugurated by Celeste Saulo. Unfortunately, she's not visible here. It's like here. So the Secretary General of WMO. And a few days later, it was inaugurated also by Antonio Gutierrez, Secretary General of United Nations. For a smaller company from Prague, for a guy who grew up in a small village of 3,000 people, it was quite a proud day when that happened. So I was really happy that my team was actually able to deliver something that is currently operational for a year. I think it will celebrate a year's birthday. So after 70 days from contract signing, we have deployed this weather radar. Let's go to one that we deployed the year I was last time in Africa, it was 2022. It was one of the first operational C-band solid-state weather radars in the world in the service of the National Weather Service. And not just some weather service, it was the Bureau of Meteorology, one of the most demanding customers. And they, back then, the head of the radar department called it the most reliable radar in their network. So we can work in very developed place. We can also work in a very underdeveloped place on Earth. This is the radar. Whichever band you want to use, it will look similar to this. Everything is integrated into the pedestal, means that the only thing you run to the radar is communication and electricity. But I will not bore you with the technical details. But let's have a look what is more important. produces world-class data, both on the reflectivity, Doppler polarization, but maybe what is more interesting and what is more applicable, to make the work easier for the meteorologists, we work really hard on our software and what we call a level 3 data. So for instance, if you look at the same situation, and this is from Brazil, this is from our radar that we deployed in South Brazil with local company Meteopress for the local civil defense agency. You may remember the Rio Grande do Sul state suffered a lot of flooding last year, and a lot of people died. There was major disruption, so that's why they invested in a weather radar. Now they are investing more. And this was one of the situations that our radar caught. So you see a lot of reflectivity, you see a hail core over there. But if you look at this image, this is the same image from the same moment. This is the estimated size of hail, which estimated that the size of hail falling down will be about 8 centimeters, which then the people on the ground actually unfortunately caught. And unfortunately, that actually happened. So the radar is able to detect these dangerous phenomena and then basically send early warnings that something like it is coming and basically warn people. And again, this fulfills our role of affordable technology protecting people sustainably around the world. So that's the case. This is the piece of software we are using for it. It's made in-house. It's based on AI. I know that right now you put AI in every presentation, in every, your bread is probably done with AI. Your cars has a lot of AI in it and so on. We have started with using artificial intelligence. Back then it was called neural networks. We started using it in 2019. And what we done was predicting the weather radar image. So basically taking the radar image, which is a picture of the sky. So it does not predict anything, just measures whatever is happening. And we forecast it 90 minutes into the future. So the forecaster could not just estimate where it's going to move, just like as you look at the radar, you see it's going my way, it's probably going to go my way in the future. So we used the AI to do this forecasting, and we used methods that were already existing, such as predicting tumors in patients, detecting behavior on the airport. So those existing neural networks that we applied on weather. Around this first idea, I built a strong team of AI engineers who now works closely with the radar engineers to do a lot of stuff with the radar using artificial intelligence. We are cleaning the data, we are filling the gaps in the data where they are, and then the crown jewel would be this warning system, where it basically select the most dangerous parts of those storms, and then project the path, time of arrival, and duration on that event. So basically, your meteorologist can have a very precise idea when it's going to hit that particular area, if that particular area has any points of interest in it, a hospital, a critical piece of infrastructure, a school, and send automatic warning to that place. So it can be either issued by a meteorologist, or you can just fully rely on that technology to send them the warning. It will be, so when you have 2,000 places in your country which you need to warn, and you have 7 systems that go in the same moment, it's very hard for the meteorologist to basically observe all of those places at the same time and issue the warnings. That is why you include this into the system. And as we heard again in the panel before my presentation, the last mile delivery. So how you get it to the people is also crucial. That is why we can also include not just radar, not just software, but also a website, a warning system that can deliver the warnings via SMS, via WhatsApp, via an app. We have an app that you can buy with the radar. So I think that is important to go from having the big radar on a hill to the pocket of the user where he gets the warning. The full chain where the people know what's happening and can react. This is all we can do. This is where our job ends, and then it's about the people on the ground, if they take action or not, but they should be warned. What I also think is, right now we don't have to build radars that pollute the air and cause harm. I pollute the air enough by flying around the world, selling the radars. I think that my radar should not do that. So we have very low power radars. This is, again, an example from Tonga. And if you see on the graph, I think the only important number is this. It's 0.0. That's how much it consumes from the grid. We generate all the electricity that the radar needs by these 12 solar panels and battery pack to go over dark days and to be to last over the night. So we have battery packs inside and we have solar panels. And this is sufficient to be fully powered, to fully power the C-band weather radar. Okay? There we go. I will not go over all the details here, but I think that one thing that I would like to stop at one topic is sustainability. I think that one thing is to get the money to get the radar into the country, but what happens 5 years down the line, 10 years down the line? Unfortunately, right now, I think that the world, there's more broken radars than functional radars, especially in the developing world, where somebody purchased the radar, had 3-year maintenance contract, that one expired, and then nobody can take over the radar. How do we fix that? First, you should not rely on any expensive parts to keep the radar running. So there should be no consumables. So you should not have to change anything in the radar. You should have a radar that's permanent. Second thing, it should be easy to maintain. It should be able to, your employees in your Met services should be able, with maybe a remote assistant via WhatsApp video call, to fix the radar and have the spare parts on one spot. I think that these things are very important and very crucial to keep the radars running. Because when we invest a couple $1 million into putting a radar into a country, these are expensive projects. They should be at least functional forever. That's my goal. I will skip this video from Tonga. How much time do I have left?
You still have 10 minutes.
All right, let's watch the video. Okay, time. So this is when we brought the radar to Tonga. I told you the logistics was a bit sketchy on that project, so we had to get everything into the country. It was a bit delayed, but Secretary General of the United Nations was coming, so I had to get my hands dirty. And we, at that moment, we were installing a second radar in Brazil as well. So that was the Rio Grande do Sul radar. So we split the team and made it first mobile because there was a lot of rain. So we had to assemble the radar in a workspace outside. Then we moved the radar to the end location. So we had a mobile radar for about 35 minutes. And then we brought it to the spot, disassembled and reassembled again. This is when the tower finally came. I was a bit delayed because to get it on an Air New Zealand flight was a bit of a challenge. It's a 7-meter tower. But all in all, it's a 2-day job to install the radar. So it's not a 2 weeks, it's not a month, it's a two-day job to install our weather radar. Careful observation from the New Zealand Met Service guys. When they started to finally believe that the radar is happening, they put their logo on it as well. They didn't want to put it before. Once they saw that it's actually happening, suddenly there was a rush to put all of the logos on it. This is the Tonga Met Service guys who are also helping. Which I think is also important to include the local guys from the local Met Service. So they create a sense of ownership and they actually understand how the radar is built and how the radar operates and how they are able to, help out with the maintenance and be able to basically own their own equipment. There we go. Radar is operational. First data that we caught. And me flying away to Brazil to oversee the second installation of that week. So that was a nice project. We were really happy about it, and it's still considered one of the crown projects. So now, the African examples. Currently, we are involved in 4 weather radar projects in Africa. The first one is Rwanda Meteorological Service. We have been involved with Rwanda for about 3 years now, 2 years now. Where first we fixed the broken magnetron radar, so they had existing magnetron radar, and even though we are specialists on solid state, and I will try my best not to ever build a magnetron radar, we still have engineers who can fix it. So if you have a magnetron radar that needs a fix, we can fix it. We will help you with that. If down the line you will consider what the Rwanda did, which is upgrade to solid state radar. So the phase 1, we upgraded it temporarily because the magnetron was kind of not sustainable in the long term. We had to salvage parts from 2 magnetrons to put one together that was working. But we upgraded it to solid state, which we call a rack upgrade, where we put, which is on the second image, where we put our rack transmitter down into the radar room. But what is more important is the phase 2, which is in progress. Right now, the radar passed the factory acceptance test. It's a full upgrade to solid state with a new pedestal. It will be a solid state 5 kilowatt C-band dual polarization radar. We will reuse the antenna because the antenna is still good. So why bring a new one? So we'll reuse the antenna that's existing there, and we'll refurbish the radome, so clean it up, patch it up, and so on. This probably has 10 more years in it. So I was also saving money, being ecological. And they got the full AI radar package. So that's a Rwanda project. This is a project we are doing with our friends from Meteopress International, MFI, who are present here. This is for Sodexam in Ivory Coast. The project is for a C-band radar, 10 kilowatt solid state. As you can see, this is the team accepting the radar on a factory acceptance test. We are also bringing a 20-meter tower, which is not my favorite part of the project. Unfortunately, we can also deliver a turnkey project, including the tower. But I think that there are, you can get towers better from the tower specialist, but you can also deliver a project with a tower. The FAT is completed. Right now, it's being delivered to the end place, and we want to try to install it. It should be installed by the end of the year, but we'll try to expedite it for political reasons. There's an election in Ivory Coast, and they would like to have the radar functional before the election so they can wave the flag. So I'm going to do my best to help out the clients because we are here for the clients. So we will try to get it before the election so everybody can cut the ribbon and everybody will be happy. But it kind of depends on the logistics and how quickly they will pass through the customs, which is not in our hands. Thank you. We are working with Ghana Meteorological Agency. You can see the factory acceptance test on the picture, which is not very visible, which is good because I am in it. It's an X-band project, 2.4 meter antenna, 800 watts solid state dual polarization. The radar is delivered, and we are waiting for Ghana Met Service to get the tower up and running. When the tower will be ready, we will get there in a moment's notice to bring the X-band radar. And this is the factory acceptance test with the team from Ghana. I think it happened in January or December. I think that the Ghana delegation was a bit surprised by the weather we had in Prague because it was very cold and some of them came in flip-flops. So whenever you come to Prague, we have full seasons and we actually get snow. So next time we will write a little notes what to expect because it was really cold for some of them. But we had a good beer in Prague, so everybody was happy at the end. And then we have a very interesting project which is happening in Senegal. It is interesting because this is the public-private collaboration that I think is crucial. British Petroleum has an offshore oiling platform off the coast of Senegal, and they want to support that operation for safety. You know, they lose a lot of money if they don't have proper information. So they went to us. Actually, they went to the industry and then selected us to bring a C-band weather radar. And just create good relationships in the country. They are going to share the data with the local Met Service for free. And we are going to also do, and they also included a lot of training for the ANASIM, for the Senegal Met Service to understand the weather radar and so on. We are still operating the radar, so we are going to be, as a Meteopress, we are going to be taking care of setting the scanning strategy, operating the radar, taking care of it on the maintenance. There's a low maintenance package, but we are going to do a lot of training on it for the local Met Service. We are going to also publish the data on a dedicated website, just like we do in Tonga, so that the data are out, and so that the local people can actually get their hands on the data as well, and can basically organize their lives based on the data that are available in the country. So I think I mentioned everything. It's a C-band, IRENE package, so full AI package with nowcasting, solar and battery package, 7-meter tower, public website, and training package. Yeah. So now, which is the right radar for you? What I believe that the radar should not be decided, which radar you get should not be decided by the skill of the salesman who sells it to you. I think that the radar that you get should be decided by which radar is the best for your particular piece on Earth. So if you look at South Africa, we can have a look at the eastern part, and it's on the borderline between S-bands and C-bands. Okay, so you can see if it's red, it's S-band. If it's green, it's C-band. If it's blue and white, it's X-band. So basically, if you ask me which radar should I get, for South Africa, I'll tell you where, which part. Because if you are here, X-band will be fine. If you are here, I will do S-band. S-band is better, okay? So we have maps for each corner of the Earth. So if you want to discuss which radar you should get, it's just about the band. Of course, I will be happy if you choose radar from Meteopress, but you can just come for an independent consultation on which radar should be suitable for you. So we know that Mauritius has an S-band radar. It's a great choice. You're supposed to have an S-band radar, right? So so we can have a look at the Central Africa as well. This is a little bit low resolution, so why don't we just have a chat and we can just discuss this when you are at our booth. So that's one decision making. Second decision making is which technology. As you can hear from my presentation, and I'm not going to go over this, I think that in 21st century, not buying a solid-state radar is like not buying a modern car, okay? It's like trying to buy a coal-powered locomotive in the age of electric cars, all right? So there are a lot of advantages. I don't want to go over the details of it, but one of the things that it should be very, that you should think about a lot is the long-term outlook of your weather radar. Let's say 5, 7, 10 years down the line. Are there going to be spare parts? And the problem is that there's very few manufacturers of spare parts for magnetron flashband radars. And there's a lot of industry going on right now, a lot of development of the solid state. So, if you look down the line, 5, 10 years, I think that's one of the key sustainability argument. The other one is about the size, unfortunate shape of the store. About the size of your weather radar. Right now, with the post-processing of the weather radar done with signal processing, modern engineering, and so on, we can now start things smaller rather than bigger. Because having operating an S-band weather radar 8.5 meters in a developing country is very hard. 8.5 meters is a 3-story building that you need to rotate. Right now, we don't have to have 8.5 meter weather radar on S-band to get to the resolution you want. You can achieve the same resolution and better by smart signal processing. So this is again something that we should discuss. We are operating about 10 of the C-band 2.4 meter weather radars around the world. So we can showcase the quality of the data around the globe, even though previously the industry only bought 1 degree beamwidth weather radar, so 4 meter C-band weather radars. The same is done in the S-band. So we can do smaller S-band with the same data. So something to also consider. Size matters. We can do smaller radars, we can do big radars. At the end of the day, it's about getting the radar to your country, getting the data to your meteorologist so you can do your job. You can protect the people and do the early warnings for all initiatives. Thank you very much for your attention.
Thank you
very much, Michael. Sorry. If you have any questions for Michael, he will be around for the next 3 days, so please do go grab him. Our next presentation is from the